what are we looking? We are looking at what will we study in climate. In climate, we will be studying about the horizontal pressure variations. Horizontal pressure variations, because we have to understand the wind system. The pressure and temperature, they are related. There are various factors that affect the temperature, and therefore these conditions will also affect the pressures. So one condition is that what latitude? Yeah, that you said equator and poles. Temperature alag hoga, pressure bhi alag hoga. Local conditions, right? We will see what do we mean by local condition. You have slope conditions. जो land water differential आप बोलते हैं, continentality भी बोलते हैं, ठीक है? The mid latitude deserts, they are within the continents. If you look at Gobi Desert, Turkestan Desert, they are in the middle of the continent, ठीक है? And therefore they have high pressure variation as compared to the oceans. If you even look at India, northern India, Himalayas, our Delhi belt, ठीक है? This is away from the sea. And therefore, during summers, it gets very, very hot. Whereas in the winters, it gets very, very cold. But in Chennai, the winters are not as severe and the summers are also not as severe. Why? Because Chennai is more near to the water, whereas the northern part of the country is away from the ocean. So this is called as continentality. The factors that also affects your temperature is the ocean currents. Warm ocean current will lead to hot conditions. Cold ocean currents will lead to cold temperature. So when there are cold temperature, there would be pressure variation. So these are the factors that are affecting the temperature, and therefore they also affect your pressure. Therefore, on our earth, right, on our earth, we have many things. One, on the earth, you have land water difference. We have variations in the form of relief. Top of the mountain versus bottom, whereas the lower atmosphere. We have slope that also affects the temperature and pattern. We have ocean currents that is affecting your temperature pattern and the pressure pattern. This is one. How far is the latitude? What is the intensity of solar radiation that we receive at the latitude? So latitudinal conditions, the intensity changing with the season, the intensity of the sunlight changes with the season, that we've also seen in the rotation and revolution. If you look at the altitude, like the latitude, there is altitude also. So here you will have tropical forest. But as you move higher in the altitude, the temperature reduces. As the temperature reduces, you can see the change in the vegetation. Where? Because the temperature is changing, vegetation will also change. There would be pressure variation there also. If you look at the ocean currents, the ocean currents influences the temperature and the pressure variations. So there are so many factors. Continentality, land water difference. The land water difference that also gets reflected. The pressure gets affected by the continentality also. So when I'm studying the horizontal pressure variations, Earth ke surface pe, there are many factors that are influencing continentality, ocean currents. You have relief, we have slopes. And therefore we need a simplified version to understand the pressure pattern. Okay, the pressure pattern. So simplified version यानी क्या, हमको कुछ models की जरूरत है. The first model that we will study in the atmospheric circulation. Atmosphere is, there is some circulation going on in the troposphere. To study that, we have to study the Hadley's model. So please write, give the heading Hadley's model. Hadley's model. Hadley पहले समझ लेते हैं, फिर हम लिखेंगे. तो Hadley जी ने बोला कि this is the earth. Your earth has no land water difference. There is no land water difference. It's a homogeneous earth. That was his assumption. He's simplifying the reality. So there is homogeneous earth. And the earth is also, the other assumption was that the earth is not rotating. That the earth is not rotating. So these are the two assumptions. He wants to explain, Hadley wants to explain horizontal pressure variation. You want to explain horizontal pressure variation. By this horizontal pressure variation, he will explain where is high pressure, where is low pressure. And on the basis of high pressure, low pressure, he will explain what is the wind system. That is, he will explain what is the global atmospheric circulation. Global atmospheric circulation. How is the wind moving? What is the circulation? So he makes two assumptions. The first assumption he makes is non-rotating earth, and the other is no land water differential. Because he's saying non-rotating earth, agar earth rotate nahi kare to what will happen? There will be no Coriolis force. There would be no Coriolis force. Okay. You know, for a fact, we know that wind is governed by various forces. One is pressure Coriolis force. The other is pressure gradient force. There is friction force. Okay. Three major forces that affects the wind. One is pressure gradient. Wind always moves from high pressure to low pressure. Pressure gradient, one. The Coriolis force that changes the direction of the wind. Frictional force that changes the speed of the wind, right? So there are three forces. As he assumes non-rotating earth, he's assuming no Coriolis force, and he's saying no land water differential. Now he wants to explain pressure pattern. So when he explains pressure pattern, he says that there is sun. Okay, there is sun here. The sun is directly heating this equator, whereas there is no direct heating of the poles. So at the equator, what will we have? We will have high temperature, we will have low pressure. At the poles, we will have low temperature and high pressure. Low temperature and high pressure. Okay. Now we also know the layering of the atmosphere, the troposphere, right? The this is your tropopause. The tropopause. यहाँ तक wind, vertical air currents हम experience करेंगे. So imagine at the equator we have low pressure. At the pole we have high pressure. At the equator, because there is high temperature, this is your equator. There is your high temperature. This is tropopause. Okay, this is equator. This is tropopause. The wind, this is high temperature. There would be vertical air currents. There would be vertical air currents. So ये earth का surface है, ये atmosphere है, layer of atmosphere. There would be vertical air currents, right? The vertical air currents would reach up to tropopause. The air will move along the tropopause. ये ढक्कन है, ठीक है? It's like a lid. Consider a jar. Okay, this is, let's say, equator. Okay, this is, let's say, tropopause. यहाँ से wind is rising. इसके बाद क्या होगा? It will have to turn. So wind rose up to tropopause. Then the wind will turn. The wind will then turn and move along the tropopause. Tropopause के along ये move करेगी. ठीक है? It is moving along the tropopause. It reaches up to the poles, and then the wind has colon. The wind will sink. Okay. And यहाँ से the wind moves from high pressure to low pressure. High pressure to low pressure. That is what your Hadley is saying. Hadley is trying to explain wind. He's trying to explain planetary wind. He's trying to explain global atmospheric circulation. He's trying to explain pressure variations. But he's simplifying. And he says that at the equator, you have high temperature. The air rises and reaches up to tropopause. As it reaches up to tropopause, then it moves towards the pole. Along the tropopause. It sinks at the poles, and then from the poles, it reaches up to the equator. Look at this. Okay. The equator is very warm. The air is rising. The air reaches up to tropopause, moves along the tropopause, sinks at the poles, and then moves towards on the surface. If I ask you, this cell, okay, consider this as a cell. This one, this is the surface winds, right? दिस इज द सरफेस, ये सरफेस पे है ना, ये सरफेस पे है. एंड ये क्या है? दिस इज द अपर tropospheric wind, upper tropospheric wind. This one is your surface winds. This one is your upper tropospheric wind. So here you can also understand like this. This is your equator. This is the poles. Or let me say, this is the equator. This is the poles. This is the poles, right? Can I say this is the tropopause? ये surface है. This is the surface. This is the tropopause, right? The tropopause is higher above the equator, whereas it is at a lower height at the poles. So here, this is equator. You have high temperature on the surface. The wind is rising. The wind is moving along the tropopause. The wind sinks at the towards the pole and move from poles towards the equator. Move from poles towards the equator. So this section is what? Surface winds. Whereas this is what? Upper tropospheric winds. That's what your Hadley says. Hadley कहते हैं, there are 2 cells per hemisphere. There are 2 cells per hemisphere. As per Hadley, there are 3 pressure belts. One is the equatorial low pressure belt. One is the North Pole high pressure belt. One is the South Pole high pressure belt. So as per Hadley, there are 3 pressure belts. Belts. Belt क्यों बन रहा है? क्योंकि homogeneous earth है. तो land water difference ही नहीं है. तो पूरा एक belt बन जाएगा. Right? So there is a belt. You have 3 pressure belts. You have 1 cell per hemisphere. Right? So there I will make you write everything. So there were 2 assumptions. One was non-rotating earth. There was one, the other was homogeneous earth surface. No land water difference. So that's what Hadley says. Hadley की 2 assumptions है. वो बोल रहा है उन्होंने insolation को account किया. Insolation को account करके बोला कि equator बहुत warm हुआ. Warm होके ऊपर गया. हवा ऊपर गई. Tropopause से move की. Tropopause से जाने के बाद ऊपर sink किया और surface पे आई. That's what your Hadley is. So please write about Hadley's model. Okay. So assumption. There are 2 assumptions. The first assumption is 1. The non-rotating earth. Therefore, no Coriolis force. There is no Coriolis force. The second is no land water differential. That is homogeneous earth. Homogeneous earth model. He accounts for, Hadley accounts for the role of insolation. The role of insolation. Equator more heated, therefore has high temperature and low pressure. Whereas poles they are less heated, therefore has low temperature and they have high pressure. They have high pressure. So there are 2 assumptions. One is non-rotating earth and there is no land water differential. Model, he accounts for the role of insolation. He says the equator is more heated, has high temperature, therefore low pressure, and poles they are less heated and therefore they have high pressure and low temperature. You can also draw your the earth. You can say that equator, this has high temperature, low pressure. At poles you have low temperature, high pressure, low temperature, high pressure. The air rises from the equator and reaches a tropopause After reaching tropopause, the air moves along the tropopause. The air moves along the tropopause and sinks, moves along the tropopause to reach the polar areas. To reach the polar areas. The air descend at the polar areas. At the polar areas. You can draw this figure. Equator, north pole, south pole. You have this as the tropopause. Tropopause. Here you have 18 kilometer. Here you have 8 kilometer. Here the air is being heated and being risen. It is moving along the tropopause as it reaches the polar areas. I will draw a different color pen. The air gets heated. The air gets heated. It moves along the tropopause. It moves along the tropopause, reaches the polar area, descends at the polar areas. So here at the equator, we have low pressure, whereas at the poles we have high pressure. And the air is then moving from high pressure to the low pressure. The air is then moving from high pressure to the low pressure. Now, one question off the track. इक्वेटर पे सरफेस पे कैसा प्रेशर है और इक्वेटर पे ट्रोपोस्फियर पे कैसा प्रेशर है? पोलर एरिया में सरफेस पे कैसा प्रेशर है और पोलर एरिया में ट्रोपोपॉज के पास कैसा प्रेशर है? Can you see the wind is always moving from high pressure to low pressure, high pressure to low pressure. You can also show this here. This is the wind rising from the equator, reaching the tropopause, cooling and descending, reaching the along the tropopause, reaching the polar areas, cooling and descending. So you have low pressure, high pressure, low pressure, high pressure. Right? This is what Hadley says. So Hadley says the air rises from the equator, reaches the tropopause. After reaching the tropopause, the air moves along the tropopause to reach the polar areas. The air descends at the polar areas. According to Hadley, there are three pressure belts. There are three pressure belts. We have three pressure belts. That is the North Pole high pressure belt, South Pole high pressure belt, and we have equatorial low pressure belt. Equatorial low pressure belts. So there are three pressure belts: North Pole high pressure belt, South Pole high pressure belt, and the equatorial low pressure belt. Okay. And there is, according to Hadley, there is one convectional cell. There is one convectional cell per hemisphere. There is one convectional cell per hemisphere. There are three pressure belts. Okay. That's what Hadley says. इसी चीज पे improvise करते हैं Ferrell. Ferrell takes the same model and tries to improvise that. Why? Because Hadley की कुछ limitation है. There are few limitations of Hadley. The limitations, जो assumptions है वो limitations है. In reality, we know that Coriolis force affects the wind. In reality, we know that there is no land-water differential. One question that is being asked to me is, why is there low pressure? Why is there a low pressure at this region? See, understand, यहाँ पे wind is rising. Okay, as the wind is rising, there will be compaction of air here, right? Tropopause is like a lid. हवा आई और यहाँ इकट्ठी हो गई. Obviously, if the air is accumulating here and then it is moving here compared to this place, which is above the equator, to this place, what should be the pressure variation? Every time understand the pressure variation is always comparative. यहाँ पे high pressure क्यों है? Wind आ रही है और wind इकट्ठी होती जा रही है यहाँ पे. The wind is accumulating here. This is a lid. इसके ऊपर जा नहीं सकती. Wind is accumulating here. So it is tightly packed here. So there would be high pressure here. But as compared to this, there is no tightly packed wind here. The wind reaches here, moves down. Wind reaches here, moves down. Reaches here, moves down. And therefore, you have a low pressure here. This is always in comparison. High pressure, low pressure is always in comparison. Okay. So this is very important to understand कि ऊपर क्या हो रहा है. Surface पे अलग काम चल रहा है, ऊपर अलग काम चल रहा है. Now, how many of you have heard the word polar vortex in the news? Have you heard the word polar vortex? A first definition that you read about polar vortex is at the pole there is a low pressure and the wind is and the air is gushing around that low pressure. तब सवाल आता है कि low pressure pole पे कहाँ है? Pressure आपको हमेशा पता रहता है कि pole पे high pressure. वो जो polar vortex आप पढ़ते हैं वो कहाँ पढ़ रहे हैं low pressure? At the upper troposphere, not on the surface. We are studying at the upper troposphere, right? Now, Ferrell tried to improve upon Hadley. What did Ferrell do? Ferrell just changed one of the assumption of Hadley. Listen to it first, then we will write. Ferrell ने एक definition, एक assumption change कर दी. क्या assumption change की? He said that the earth is rotating. And the second assumption was no land-water differential. So as per Ferrell, again there are two assumptions. One is there is a rotating earth. The other is there is no land-water differential. If there is rotating earth, therefore he will account for Coriolis force. Now what does Coriolis force do? When Ferrell accounts for the when Ferrell accounts for Coriolis force क्या करता है? Coriolis force deflects the wind towards right in the northern hemisphere, and it deflects the wind towards the left in the southern hemisphere. Now, suppose a wind is moving from A to B. Okay, as the wind will move from A to B, the distance that it covers, okay, is let's say X. As the wind covers X distance, the wind gets cooled. Okay, अभी क्या समझना है? This is a hot wind. If the hot wind covers let's say X kilometer, it will become cool. Okay, the wind is moving from A to B. As it covers the X kilometer, it will become cool. If the wind gets deflected, if the winds get deflected, ये जो always understand the principle. The shortest distance between 2 points is a straight line. If there is a deflection, the wind will cool even if it reaches a place which is nearer as compared to B. ये बोलना चाह रहे हैं कि ये तो शॉर्टेस्ट डिस्टेंस है, ये इतना डिस्टेंस ट्रैवल किया तो ठंडी हो गई. अगर डिफ्लेक्शन हो रहा है तो विंड विल नॉट नीड टू गो एज फार एज बी टू कूल. द विंड विल कूल इवन इफ इट रीचेस अ प्लेस नियरर, राइट? तो व्हाट इज हैपनिंग इज फेरेल जब बात कर रहे थे कि विंड है वो इक्वेटर पे राइज करती है, वो यहां तक पहुंचती है पोलर रीजन तक. पोलर रीजन पहुंचने के बाद ठंडी होती है और डिसेंड करती है. A cold wind is heavier. A cold wind will descend. So it says that the wind rises along the equator, it moves along the tropopause, it reaches the polar areas, it cools and it descends. The moment you account for Coriolis force, Will the wind have to travel as far as pole to cool? Yes or no? My question is, the moment you account for deflection, अब डिफ्लेक्शन अकाउंट कर रहे हो, will the wind have to reach as far as pole to cool, या जल्दी ठंडी हो जाएगी? जल्दी ठंडी हो जाएगी, राइट? क्योंकि डिफ्लेक्ट कर रही है, डिफ्लेक्ट कर रही है तो उतना उसको दूर जाना ही नहीं पड़ेगा, पहले ही ठंडी हो जाएगी. तो यस, तो as per Ferrell, the wind cools even when it reaches 30-degree latitude. It doesn't have to travel as far as 90-degree latitude to cool. I'll just repeat this thing. The point that I'm saying is the shortest distance between 2 points is always a straight line. So A to B, the shortest distance would be a straight line. If you don't account for deflection, the wind is traveling straight. If the wind is traveling straight, it will have to reach poles to get cooled. The moment you account for deflection, the wind can cool even before, right? Even if it has not reached the 90-degree latitude, right? जिसको समझा ठीक, जिसको नहीं समझा बस इतना समझ लो. हैडली ने बोला विंड पोल तक जाएगी ठंडी होगी, फेरेल ने बोला नहीं, उसके पहले ही ठंडी हो जाएगी, बस. ठीक है, फेरेल ने बोला 30 डिग्री पहुंचेगी और विंड ठंडी हो जाएगी. हैडली ने बोला वो 90 डिग्री तक जाएगी और ठंडी होगी, बट फेरेल ने बोला वो 30 डिग्री जाएगी और वो ठंडी हो जाएगी. That's what Ferrell says. So there are two things. One is the rotating earth. He assumes rotating earth, and therefore he assumes for Coriolis force. He assumes for Coriolis force, and he says that there is no land water differential. And Ferrell says that the wind rises along the equator, the wind moves along the tropopause, the wind reaches at 30-degree latitude, cools, and therefore will sink. As it sinks, as it is sinking, there will be high pressure here, there will be low pressure here. Now we know at poles, the poles are always cool. The pole पे क्या होता है? High pressure. So यहाँ से wind आ रही है from poles up to 60 degree. At 30 degree से भी जा रही है up to 60 degree, क्योंकि 30 degree पे भी high pressure. यहाँ पे wind आई, wind dynamically उठ जाती है. Thermal reason के कारण नहीं उठ रही है. Thermal reason यानी गर्म हुआ तो उठेगी, ठंडी हुई तो डिसेंड करेगी. इसके कारण नहीं, यहां से आ रही है ठंडी विंड पोलर एरिया से और ट्रॉपिक से आ रही है गर्म विंड. एज द कोल्ड एंड द वार्म विंड they are meeting at 60 degree latitude, they will rise, they will uplift, and therefore here you have the upliftment of the wind, and then the cell gets completed. The cell gets दोनों ही डायनेमिकली उठेगी. ठीक है, हाँ, तो इसका ये मतलब है कि कंपैरेटिवली वार्म एयर ज्यादा राइज करेगी, पर कोल्ड एयर भी राइज करेगी. यहाँ पड़ी नहीं रहेगी, विंड हैज टू राइज. तो कोल्ड वार्म एयर विल राइज मोर, बट देयर हैज टू बी कोल्ड एयर आल्सो. ये जो कोल्ड विंड है और ये जो वार्म विंड है, इन दोनों के बीच का इंटरफेस हो रहा है. द कोल्ड विंड एंड वार्म विंड, यू माइट हैव स्टडीड कोल्ड फ्रंट एंड वार्म फ्रंट. यही टेम्परेट रीजन्स में होता है. 60 डिग्री इज टेम्परेट रीजन्स, द एरियाज ऑफ यूरोप, द टेम्परेट रीजन्स ऑफ एशिया एंड नॉर्थ अमेरिका. ठीक है, यस. नाउ एक बार फिर से इसको समझते हैं. दैट्स व्हाट योर Ferrell said. So as per Ferrell, is there one cell per hemisphere? No, there are 1, 2 and 3 cells per hemisphere. As per Ferrell, there are 3 cells per hemisphere, and as per Ferrell, there are 3 cells per hemisphere. And as per Ferrell, there are 7 pressure belts. There are 7 pressure belts. 1, 2, 3, 4, 5. नहीं, यहाँ पे मिड लैटिट्यूड भी आएगा. हाँ, यहाँ पे भी आएगा. ठीक है, so there will be a 7 pressure belt. Thank you, Imran. ठीक है. Now that is what is Ferrell's model. तो Ferrell के हिसाब से there are 3 pressure cells. Ferrell के हिसाब से there are 7 pressure belts. And Ferrell's Ferrell also explains what? Ferrell also explains your planetary winds. The planetary winds, like we will see how does he explain the trade winds. He explains westerlies. He also explains your polar easterlies. We will see how does he explain. But abhi ke liye, what are we doing? We are understanding global atmospheric circulation. We understood that global atmospheric circulation is affected by pressure variations. Okay, is affected by pressure variations. The pressure variations on the earth can be too many, right? If you actually look in reality, ये जो pressure belts बन रहे हैं, right? ये एक pressure equatorial low pressure belt, a polar high pressure belt, you have a subtropical high pressure belt, you have a subpolar low pressure belt. Have you heard these names? Equatorial low pressure belt. We have a tropical high pressure belt. We have a subpolar low pressure belt. We have a polar high pressure belt. ये तो belts है ना? ऐसा कौन कह रहा है? ऐसा फेरल कह रहा है कि belts हैं. क्यों कह रहे हैं belts हैं? Because he have not taken into account land water difference. But in reality, there are no pressure belts. In reality, there are pressure cells. In reality, there are pressure cells. I think I forgot to attach that. In reality, you will understand there are small pressure cells. आपके land पे कुछ pressure cells होते हैं, आपके वाटर पे कुछ प्रेशर सेल्स होते हैं, लैंड पे कुछ प्रेशर सेल्स होते हैं, वाटर पे कुछ प्रेशर सेल्स होते हैं. तो रियलिटी में बेल्ट्स नहीं है बहुत ज्यादा. रियलिटी में बेल्ट्स इक्वेटर के पास है. रियलिटी में बेल्ट पोलर रीजन के पास है. रियलिटी में बेल्ट सब पोलर पे भी बेल्ट्स हैं, स्पेशली साउथ में, क्योंकि आप देखोगे कि देयर इज नो मच लैंड वाटर डिफरेंस. सो इन रियलिटी, इफ यू लुक, in reality you have equatorial low pressure belt. Yes. In reality you have a polar high pressure belt. Yes. A polar high pressure belt. Yes. You have a subpolar low pressure belt because there is not much land water difference. But otherwise you will see that there is no belt. There are cells. There are pressure cells. And the pressure cells, they are keep on changing. इसीलिए the global atmospheric circulation is not as simple as these models point out to be. They're not as simple as these models point out to be. But हमको समझना तो पड़ेगा. इसलिए we are making use of some models. For them, some simplifying assumption. So please write about the Ferrell model. Please write about the Ferrell's model. Please write this, the assumptions. The assumption. 1, non-rotating earth. Rotating earth. Assumption is a rotating earth. A rotating earth. And therefore he accounts for Coriolis force. He accounts for Coriolis force. The second is no land water differential. No land water differential. As he accounts for Coriolis force, the wind from the equator, does not have to travel till poles. The wind does not have to travel till poles to cool, but the wind rising from equator does not have to travel till poles to cool, but will cool even if the wind reaches 30-degree latitude. A to B, wind travels from A to B to cool when traveling in a straight path, when traveling in the straight path. And if there is deflection, in a case of deflection, wind cools earlier. Wind cools. Wind travels from A to B to cool when traveling in the straight line, and if there is deflection, the wind will cool earlier. In case there is a deflection, the wind will cool earlier. जिसको नहीं समझा उतना समझो कि फेरेल ने बोला 30 डिग्री पे आके ठंडी हो जाती, ठीक है. Now model. Now the model. I'm drawing the graph first. I'm drawing the figure first. This is equator. Okay, the air is rising. The air rises. It moves along. The air rises and moves along the tropopause. Moves along the tropopause. Moves along tropopause and cools at a 30 degree latitude. And cools at 30 degree latitude, and therefore this is descending. Therefore, wind descends. Okay. You can write pole. There is high pressure. There is low pressure. Okay. From the pole, the wind is moving. So, you can write on the Earth's surface. From the polar area, the wind moved towards a 60 degree latitude. From the polar areas, the wind on the surface of the Earth is moving towards the 60 degree latitude. Is moving towards the 60 degree latitude. Okay. This is 30 degree. This is 0 degree. And also write here only, on the Earth's surface, from 30 degree latitude, the wind is moving towards 60 degree latitude. Towards 60 degree latitude. एक दो कंपोनेंट है, एक अर्थ सरफेस वाला कंपोनेंट है और एक अपर ट्रोपोस्फियर वाला कंपोनेंट है. सो सरफेस में क्या हो रहा है, इवन 30 डिग्री से 60 डिग्री तक विंड जा रही है और पोलर वाली विंड भी 60 डिग्री तक आ रही है. तो सरफेस में क्या हो रहा है, यहां से तो पहले विंड उठी, विंड मूव्ड अलोंग द ट्रोपोपॉज, कूल्ड एंड डिसेंडेड. फ्रॉम 30 डिग्री ऑन द सरफेस ऑफ द अर्थ द विंड इज मूविंग टुवर्ड्स 60 degree, and also on the surface from the pole the wind is moving towards the 60 degree, right, towards the 60 degree. You can then write at 60 degree latitude, at 60 degree latitude, cold polar winds and hot winds from tropics are forced to rise. They are forced to rise. Are forced to rise. In a bracket, you can write dynamic pressure. Dynamic pressure. At 60 degree latitude, the cold polar winds and the hot tropical winds, they are forced to rise, and this is called as dynamic pressure, inducing a subpolar low pressure, inducing a subpolar low pressure towards inducing a subpolar low pressure belt on the Earth's surface. On the Earth's surface. I will explain this. At 60 degree latitude, the cold polar winds and the hot tropical winds, they are forced to rise. वो खुद नहीं उठ रहे हैं बिकॉज बहुत ठंडी है या गर्म है. They are forced to rise. As they are forced to rise, what will be? Here you will have a low pressure, a subpolar low pressure. And then एक बार उठने के बाद they will complete the cell. They will complete the cell. ये जो wind है जो ट्रॉपिक से आई है वो इक्वेटर की तरफ भी जाएगी, दोनों तरफ जाएगी, यहाँ पे भी और यहाँ पे. It will go both the ways. Now what is happening? What is happening at 60-degree latitude? At 60-degree latitude, there is, yes, it will descend. Obviously, it will descend. ना यहाँ पे भी तो wind descend करेगी. We will write about each of these cells. अभी के लिए सिर्फ मॉडल पे डायग्राम पे लिखो, ठीक है? अब understand what is happening. We will understand each of these cells. We will understand each of these cells. But मोटा मोटा समझो क्या हो रहा है. इक्वेटर पे विंड राइज कर रही है, विंड ट्रोपोपॉज तक जा रही है, विंड इज राइजिंग एट द इक्वेटर, विंड इज reaching up to tropopause, the wind moves along the tropopause, the wind cools as it reaches 30 degree and it sinks. And it sinks. As it sinks, one section of the wind is moving towards 60 degree. One section is moving towards equator. Okay, this is one section, this is one section. This cell is completed. Okay, wind is rising from the equator, reaches up to tropopause, moves along 30 degree, cools. As it cools, it sinks. As it sinks at 30 degree, one section moves towards the subpolar region, one towards the equator. And now also look at from poles, what is happening. From poles, the cold wind is coming. The cold wind is coming. At 60 degree, this cold wind and this warm wind, they are forced to rise. What will happen? We will see. As they are forced to rise, you will have a low pressure at 60 degree. As it is forced to rise, it reaches the tropopause. One section moves towards the polar areas, one section moves towards the tropical areas. This cell is also completed. The one that moves towards the polar areas descends at the surface on the 90 degree, completing the third cell also. I'll just repeat. The wind from the equator is rising. As it rises, it reaches the tropopause, it moves towards the tropic region. As it reaches 30 degree, it cools. One section moves towards the equator, the other section moves towards the subpolar regions. From the equator, cold wind is coming. Both of them, they are dynamically forced to rise. Here, therefore, you have the low pressure. As it reaches the tropopause, one section moves towards the polar areas, one section moves towards the 30 degree. Again descends, completing these two cells, three cells also. Now, what is happening at 60 degree? Why am I saying that the winds are forced to rise? So understand, a cold wind is coming, a warm wind is coming. The tendency of the cold wind is to descend, to sink, whereas the tendency of the warm wind is to rise. As the warm and the cold winds are coming, right? What will happen? Obviously, the tendency of the warm wind will be to rise, whereas the tendency of the cold wind will be to be at the bottom. But overall, क्या हो रहा है? Overall rise हो रहा है. पूरी wind, they will rise, and therefore they are forced. They are dynamically forced. Dynamic यानी, see, there are two types of pressures. One is thermal pressure. Thermal pressure that has inverse relation to temperature. Okay, thermal pressure. That is, if there is high temperature, there will be a low pressure. That is at the equator. So there are two types of pressure. Understand? Pressure can be of two types: thermal pressure, dynamic pressure. Thermal pressure क्यों होता है? क्या जगह गर्म है कि ठंडी है? उसके बेसिस पे प्रेशर डिटरमाइन होगा. डायनेमिक प्रेशर क्यों होता है? मूवमेंट ऑफ विंड के कारण होता है. डायनेमिक मींस देयर इज सम मूवमेंट, नॉट स्टैटिक. डायनेमिक. एंड व्हाई इज दिस प्रेशर? Because of the movement of the wind. So we have a dynamic pressure here because of the movement of the wind and not because of the thermal reasons. So this is what we have drawn in the diagram. Okay. So at 30 degree, will there be high pressure? Yes. At equator, you have low pressure. At tropics, at subtropics, what do we have? Subtropic high pressure belt. At polar, we have polar high pressure belt, and at sub we have a subpolar low pressure belt. Yes, Shweta, yes, Priya. You have equatorial low pressure belt, subtropic high pressure belt, you have a subpolar low pressure belt, and you have a polar high pressure belt. As per Ferrell's model, there are 7 pressure belts. There are 7 pressure belts. Equator, low pressure, because of high temperature. Because of high temperature. At poles, we have low pressure. Or you can write 1 equatorial low pressure because of high temperature. Second, a 2 pole. There are 2 poles, North Pole and South Pole. Okay. So we have 2 high pressure belts, 2 high pressure belts because of low temperature. Because of the low temperature. And you can write all of these are thermal induced. They are thermal induced in nature. All of these are thermal induced in nature. So 3 pressure belts, 1 equatorial low pressure belt and 2 polar high pressure belts. They are thermal in nature, thermal induced in nature. Then write the third point. You have 2 subpolar low pressure belts. 2 subpolar low pressure belts because of the wind movements. Because of the wind movement. And we have 2 subtropical high pressure belt. Again, because of the wind movement. And therefore, all of these are dynamic induced. They are dynamically induced. High pressure bhi kyun ban raha hai? Because wind thandi ho gayi aur gir gayi. Movement of wind ke karan hi, right? It's not because of sun's influence. Then right, the air rises at the equator. Air rises at the equator and cools. The air rises at the equator and cools at a 30-degree latitude. And therefore, it sinks at 30-degree latitude, creating a high pressure on surface. Creating a high pressure on the surface. Air from 30-degree latitude and air from 90-degree latitude are moving towards the 60-degree latitude. In bracket, you can write on Earth's surface. These 2 winds are of contrasting nature. They are of contrasting nature. You can write cold polar winds and warm tropical winds. And therefore are forced to rise up. They are forced to rise up, inducing a subpolar low pressure belt. Inducing a subpolar low pressure belt. Now you can draw this. A question मुझे बताइए. This is equator. This is pole. This is north pole. This is south pole. Equatorial पे low pressure. North pole पे high pressure. South pole पे high pressure. ये dynamically induced है कि thermal? क्या ये movement of wind के कारण है कि वैसे भी ऐसा ही होता? वैसे भी ऐसा ही होता. तो just because वहां पे wind गिर रही है, ये वाला wind ऊपर से गिर रहा है, इसीलिए high pressure नहीं है. ये high pressure already है because of the low temperature. This is low pressure because of the high temperature. This is a high pressure because of the low temperature. And therefore, these 3 are what? These 3 are thermal induced. These 3 are thermal induced. What have I written here? Air from 30-degree latitude and the air from 90-degree latitude are moving towards 60-degree latitude on the Earth's surface. These 2 winds are of contrasting nature. Cold polar winds and the warm tropical winds, and therefore are forced to rise up, inducing a subpolar low pressure belt. ये already हमारे प्रेशर बेल्ट्स टेम्परेचर की कंडीशन के कारण है. Okay, this is thermally induced. But this one, and this one, that is your subpolar low pressure belt, a tropical, subtropical high pressure belt. Similarly, a subpolar low pressure belt and subtropical high pressure belt. Yeah, 1, 2, 3, 4. These are what? These are dynamically induced. These are dynamically induced. Okay. These are dynamically induced. And what is happening? Air is rising. The air is moving along the tropopause. The air cools, sinks, completes 1, completes 2. Yahan se wind is coming. Cold winds. The winds and they are forced to rise up. And then again, they complete the cells. They complete the cell. Equator pe, the wind is rising. The wind rises, reaches up to tropopause, moves towards the tropics, cools and sinks, One moves towards the equator. The other moves towards the subpolar areas. The cold polar winds come. They meet at 60 degrees. They are forced to rise. And then this cell also gets completed. This cell also gets completed. This cell also gets completed. They are forced to rise. This cell gets completed. This cell gets completed. Can you see 3 cells per hemisphere? Can you see 3 cells per hemisphere? Ye hai, this is called as Hadley cell. This is called as polar cell. And this is called as the Ferrell cell. This is called as the Hadley cell. This is the Ferrell cell. And this is your polar cells. So as per Ferrell, there are 3 cells per hemisphere. That is the Hadley cell. You have the Ferrell cell, and we have the polar cell. What is the pressure conditions in the upper troposphere? Here you have the low pressure. Here I said at the equator, you will have the high pressure. And in the polar regions, you will have at the tropopause, you will have the low pressure, right? You will have the low pressure. कार्तिके बस ये 2 ही प्रेशर्स होते हैं. ऊपर अगर आप देखोगे ना ट्रोपोपॉज पे, तो इधर बहुत ज्यादा, ये दोनों डायनेमिकली इंड्यूस्ड है. ये वाला रीजन और ये वाला रीजन डायनेमिकली इंड्यूस्ड है, बट ये वाला और ये वाला थर्मल इंड्यूस्ड है. तो ये इतने पावरफुल होते ही नहीं है. अपर ट्रोपोस्फियर में 2 मेजर प्रेशर बेल्ट सेल्स होते हैं, हम 2 मेजर प्रेशर वेरिएशन होते हैं, इक्वेटर के पास और पोल्स के पास. बस ये दोनों इतने पावरफुल होते नहीं है कि वो इन्फ्लुएंस कर सके. सिर्फ ये और ये होता है. इसके लिए यू विल हैव टू अंडरस्टैंड द अपर ट्रोपोस्फेरिक कंडीशंस. दैट विल रिक्वायर टाइम, बट अभी के लिए जस्ट अंडरस्टैंड द सरफेस कंडीशंस. ओनली दीज 2 आर पावरफुल. कार्तिक, ओके, अभी के लिए इतना समझते हैं. इक्वेटर पे लो प्रेशर है, सब ट्रॉपिक्स पे हाई प्रेशर्स हैं, सब पोलर पे लो प्रेशर है और पोलर पे हाई प्रेशर है. ठीक है, इसमें से इक्वेटोरियल वाला 1, 2, 1, दिस इज योर थर्मल इंड्यूस्ड. द पोलर्स, दे आर आल्सो थर्मल इंड्यूस्ड. सो दिस इज 1, you have 2, we have 3, and we have 4. Again 5, 6, and 7. So this is thermal, dynamic, thermal, dynamic, and thermal. So 3 of them are thermal induced, equatorial low pressure belt 1, 2 polar high pressure belts, and the 2 subtropics and 2 subpolars, they are dynamically induced. Now, this is what is Ferrell's model. Now, this one, That is what is a Ferrell's model. So Ferrell, he's trying to say there are 3 cells per hemisphere. There are 7 pressure belts. 1, 2, 3, 4, 5, 6, 7. Okay, that's what Ferrell said. Ferrell says. And on this basis, Ferrell also explains your planetary wind. So what does Ferrell explain? Ferrell explains trade winds. Ferrell explains polar easterlies, westerlies. Okay, and he also explains that why is the subpolar regions having rains. He also explained why is the tropical belt is having deserts. We will see this. Okay? But he cannot explain these things. Okay? He cannot explain what is happening in the upper troposphere. He cannot explain the local variation, the regional variations. He cannot explain that. So pehle isko samjhte hain, what does he explain and how? So abhi tak what have we done? We understood that Ferrell explained pressure belts. Ferrell explains the pressure belts. He explained the pressure belts. He explained your equatorial low pressure belt, subtropical high pressure belt, subpolar low pressure belts, and polar high pressure belt. You draw this with me. Okay? Draw this figure that he have already explained this. Subtropical high pressure belt, subpolar low pressure belt, and the polar high pressure belt. ये उन्होंने explain किया हुआ. We know that the wind always moves from high pressure to low pressure. Okay. Now, as he accounted for Coriolis force, so these are belts as per Ferrell, and wind moves from high pressure to low pressure. And he also accounted for Coriolis force. Now, because he accounts for Coriolis force, what does that happen? The wind will deflect towards right in the northern hemisphere, and it will deflect towards the left in the southern hemisphere. Right kiska? To the direction of the wind. Okay. So if I take into consideration this one, okay, this, you will have to move towards the right, right? The movement will be towards the right. Here also, the movement will be towards the right. But right kiska? In the direction of the wind. So ऐसे हो जाएगा, ऐसे हो जाएगा, ऐसे हो जाएगा. Right? Here also in the right towards the direction of the wind. This is left towards the southern hemisphere. It is left towards the southern hemisphere. Yes, so the wind is deflecting towards the right in the northern hemisphere, whereas the wind is deflecting towards the left in the southern hemisphere. And therefore, Ferrell could explain what? He could explain the trade winds. Trade winds kaise move hoti hai? Trade winds are easterlies, right? So therefore, because Ferrell accounted for Coriolis force, he could explain trade winds, the trade winds. Okay, trade winds are what? Northeasterlies and southeasterlies. So he could explain north, southeast and the northeast trade winds. He could explain them. He could also explain the westerlies. He could explain the westerlies. Here you can see westerlies. You can see westerlies. They are coming from west to east. So he could explain westerlies, west to east. He could explain trade winds, that is northeast and southeast. If you look at the cardinal points, you have north, south, west, east. Okay, southeast would be like this, northeast would be like this. So he could explain northeast as well as southeast trade winds. He could explain westerlies, and he could also explain your polar easterlies. Polar easterlies, the winds that are coming from the polar regions are appearing to come from the east direction. Direction samajh aa raha hai? Are you able to understand? This is westerlies. Why it is coming from it is moving from west to east. These are easterlies. They are coming from northeast. The northeast. They're coming from southeast. Okay. So he could explain all the direction of the planetary winds. But he could not explain, this is at the global level, right? This is happening at the global level. But he could not explain what will happen at the local level, what will happen at the regional level. Moreover, ये तो उन्होंने explain किया. इसके अलावा he could also explain two things. Anybody, do you have any issue in the direction of the wind? Why is this called as easterlies? They are coming from northeast direction. They're coming from the southeast direction. They're coming from west to east. They're going from west to east. Again, they are coming from the east side. The east side. North, west, south.
Northeast is like northeast direction.
Northeast direction क्या होगा? ये है north, ये है south, ये है west, ये है east. तो northeast ऐसा होगा? Can you correlate to this? Can you correlate southeast to this? Yellow color, southeast and northeast. तो ऊपर northeast trade winds है, नीचे southeast trade winds है. जो आपकी southwest monsoon winds है, what are those? ये जो southeast trade wind है, after they cross the equator, they turn right, and therefore they become like this. So southeast winds, after crossing the equator, they turn right, and they become southwest. This is southeast, and this is southwest. Southwest is like this. Got it? The winds are named after the direction they are coming from. They are coming from this direction. They are coming from this direction. Okay. Okay. What is he trying to explain? He is trying to explain the direction of the planetary winds. He is successfully explaining the direction of the planetary winds. Also, Ferrell could explain that why there are deserts in the tropical belts. In the tropical belt. What do we have at tropics? At the tropics, we have subtropic high pressure. When there is high pressure, if there is high pressure on the surface, will the air rise or not? अगर high pressure, equator पे low pressure होता है तो air rise करता है. पर already अगर surface पे high pressure है, तो air will not rise, the air will sink. If the air will not rise, can it give rainfall? No. As there is high pressure, it will not rise. If it will not rise, it will not give rainfall. What will happen then? At subtropics, we will have deserts. So he could explain why there are deserts in the subtropics. And he could also explain why there is rainfall in the subpolar belt. Because subpolar belt पे क्या है? Low pressure, right? Dynamically induced low pressure. Therefore, it could explain the rain in the temperate belt. Rain in the temperate belt, right? European region, Britain region, you have a lot of rain there. Okay, this is what is he could explain. So he could explain all these three and deserts in the tropical belt and the rainfall in the subpolar belt. But he could not explain, Ferrell could not explain the local winds. He could not explain regional winds. He could not explain the upper tropospheric condition, the upper tropospheric conditions correctly. If you look at this one, this, okay, यहाँ पे north to south है, ऊपर आपका south to north है, यहाँ पे south to north है, ऊपर north to south है. तो वो बोल रहे हैं ऊपर की जो conditions हैं, they are mirror opposite of the surface conditions. But in reality, this is not correct. In reality, ऊपर का जो system है, वो बहुत अलग system है. Therefore, he could not explain the upper tropospheric conditions in a nice manner. Okay? So he could not explain this. So what he could explain? He could explain trade winds. He could explain polar easterlies. He could explain the westerlies. He could explain why subpolar regions have rainfall and cyclones. he could explain that why deserts are in the tropical belt, but he could not explain the upper tropospheric circulations correctly. He could not explain the local and the regional variation. And one of the assumption that there is land water contrast, this assumption is not correct. The assumption is not correct, and therefore this is also a limitation. This is also a limitation of the Ferrell's model. Okay, if you look at the deserts, you will look at the deserts, they are majorly in the subtropical belts. The deserts, Sahara Desert, look at the Atacama Desert, you look at the Great Australian Desert, the Namib Desert, ये सब subtropics पे ही हैं. These are all at the subtropics. This line, the Tropic of Cancer is shown here. The Tropic of, Capricorn and the Tropic of Cancer is shown. So look at Sahara Desert, Thar Desert, Atacama Desert, Great Australian Desert, Arabian deserts. They are present along what? They are present along the tropics, the subtropical high pressure belt. Yes. So this is your Ferrell's model.